when you're doing a question like this, the first thing you need to do is
do a
graphing
question.
It's going to be.
Right, this is
one
out of your review
the slope
section again.
Find the equation.
I didn't want to do all of the ones out of
find where it cuts the x-axis. Okay, so if we start
so for this one here,
you've got your function e to the x, take x.
Alright, so with my
first bit,
so the thing I need to do here is I need to say when x is equal to 0,
we have to discuss as it goes to minus
infinity
to do the second
ln of 0 squared plus 3.
We have to sketch
So that's simply just going to be ln of 3. So my point is in fact 0 ln 3. First thing I'd probably do with any question like that is I'd put it into my derivative
and then I graph it. Okay, so if I graph it, that's going to be equal to. Well, I don't have to think about decreasing. Simply put that over the bottom line there. Gets to the point, and then I just have to drive the top line, which is equal to. Alright, so that will make my life easier if I actually see what's going on there.
Alright, so now if we go to doing our first bit, alright, so obviously I have to. I'm expected to derive that. So part A, I'm expected to derive that. So f dash of x.
That's equal to.
Help me out here.
The first bit's easy, isn't it? So that's going to be e to the x equals 0, and then the next bit's going to be x, simply take 1. Isn't it?
Is equal to simply
we have stationary
2 times by 0
points
all over 0 squared plus 3,
equals 0,
which is equal to 0 on 3. When that's equal to 0, what happens?
That's easy, isn't it?
E to the x take 1 equals 0,
because then it just
therefore e to
that
the
my
x
equation on my line
is in fact equal to 1.
Right? Just equal to,
and so therefore you can say x is equal to
y coordinate, isn't it? ln.
Well, let's do it the long way,
which we know is
y take ln of 3 all over x take 0.
If we want to find our point 0 over here,
when I times this up over here, I've got y take ln of 3.
We're
it's
going
equal
to
0 times by
when
x
that's equal to 0, we know f of x
that
1. F of 1 is going to be equal to.
So therefore,
e to the 0
y equals 0 ln of 3. Now, if I did want to save some time,
looking at, I could just
is in
go
fact
straight to
0, 1,
and that
so
recognises
my line y
what we see in our graph over here. I don't know what that actually is.
We see that as our graph.
That's about
1 point something. And so, what would we classify that as? Now, the thing is,
we classify that as a local
The question
min.
Says the first thing I should do though is I should do a sign diagram.
So when does that cut?
So I know that's at 0. I've got f dash of x. It's a min.
When does that cut the x-axis?
So therefore, local min.
When's that ever going to? When's
at 0, 1.
Again, I haven't really done anything with my sign diagram, but used my graph. Okay, that should do that. I do know.
Alright, so I've done that, classified my stationary points, done that bit there. Discuss
what would
as
a
x
line
goes to minus infinity.
What would a line
like this? Part B, we know our function f of x is in fact e to the x. Okay, so if I did a line which is as x goes that would be minus infinity, what happens? It goes.
Well, we know that e to the minus x is going to be a big number or a small number. Isn't that what that's actually equal to? It's going to be a big number or a small number. When's that going to be a very small number, isn't it? Never. Okay.
And we know that plus
the x-axis, is it?
It's going to be
so essentially
so that's going to basically get really small
for you.
Alright, so that goes to 0. Alright, we know that minus x is actually going to go to be x-axis. That's going to go to be plus infinity.
And by in fact sketching it sometimes,
so if one's going to 0, one's going to go to plus infinity,
but you actually understand what's going
that f of x
in this particular case.
So essentially when we're doing a question that is like this, and you've got some of those at the start of 5e, as x goes to,
what we've got here is to go through the process. The process is simply
plus infinity.
We find the point.
We
find the slope.
E to the x
that point
is going to go off to infinity. Same process what we've done before. And minus e minus x is going to go off to minus infinity.
Rearrange that now. If you have 1 over e's and e's and here, this value here, the e to the x, impossible. Right?
It's going to be bigger, isn't it?
Before I let you go,
therefore f of x
if I get something like
is going to go off
to the minus 3
infinity,
I'm expecting e. If I'm not sure about that, over e,
I've got a graph on my calculator, which I can see,
the same.
that's going to go off to plus infinity as it goes
logs.
negative, and it's going to go to plus infinity
So
as it goes
if
positive.
I've got something like that, I get that from that. I would expect that you will write
reasoning
that in that particular form.
Yes,
if I've got
it'd be
something
good
like
to do
e
it.
to the minus 1,
Basically, you mark for saying f goes to plus infinity, f of x goes to plus
if
infinity.
I've got 1
That's what you
over
mark for.
e
Right, so
squared,
doing that.
sorry.
The next bit says do the second derivative. What am I expecting for my second derivative?
E to the minus 2, then I'm expecting you to see that as actually e squared. I'm expecting it to be concave.
You want to write
or convex or powers, I'm sorry. So C, if my f dash of x is equal to e to the x take 1, then my f double dashed of x is going to be simply e to the x. And so if we do a sign diagram for that, f double dashed of x, we know that's going to be positive because we know e to the x is always greater than 0. So therefore, always, it's always convex. And we can see from our graph that it is always convex, isn't it? Okay, so that's the interpretation for that. And then the next part of that is to actually graph it. Alright, so if we graph that, it's simply just sketching that graph and putting the local min on. I won't worry about doing that because of time. The next bit, it says deduce e to the x is greater than x plus 1. Alright, so if that's the case, if e to the x is greater than x plus 1, what do we know? We know our local min is in fact at 1. So we know that this particular thing here, which is f of x is in fact greater than or equal to 1, because 1 is my minimal value, isn't it? We know that f of x is in fact e to the x, take x, greater than 1, and therefore e to the x is greater than or equal to x plus 1. And that's what I had to show. It's a bit trivial, but it's basically saying, you know, can you use what you've already been given to do something that's trivial? Right? Deduce that information based on that.